Hi, and welcome to the Assembly Edge podcast. I'm Chris Torrance. In today's episode, we're going to continue with our Apple II emulator that we started last time. Today, we'll be adding more addressing modes, as well as looking at adding some unit tests, including how to integrate unit tests in with Github. So let's get started. Last episode, if you recall, I started building my Apple II emulator. Here's what it looks like in the browser. If I hit refresh, you can see it running. Right now it's just filling text page 1 with a bunch of ASCII characters. I actually started the application by going over to the terminal and typing npm start in my TypeScript directory. That compiled the code and then started up a browser. Let's go back now to my code and see what it currently looks like. If you'll recall, I had several different files for the emulator. The first one here was the display file, which set up the text window as well as the output at the bottom. And this is also where I put a rudimentary program just to demonstrate filling up text page 1. The next file that I had was the actual interpreter, which is taking the instructions and running them one after another. And this had the process instruction function in it that did just that. And then I had an instruction file which contained all of the 6502 instructions, as well as things like the various addressing modes. And finally, the last file was the assembler, and this took the code from my display file and just compiled it into 6502 machine code. Now, since the last episode, I've added a few instructions, and this was primarily just to flesh out the different addressing modes. So if we scroll down to the bottom of the instructions file, you can see we now have a lot more, and specifically I've added in all of the different LDA commands. So for example, in my first episode, I think I only had LDA for immediate mode, which just loads a single value. But now I have various modes such as loading from the 0 page, loading from an absolute value in memory, as well as some of the more esoteric ones like loading with an offset of X or Y, and then the indirect ones. In addition to adding more instructions to my emulator, I've also gone ahead and started doing some unit testing. This will be really valuable when I add more instructions and also begin to put in the actual ROM code just to make sure that everything is working properly. So to do this with npm, there's a couple different steps. The first thing you need to do is actually write the tests themselves. This is using npm and jest for the testing. And the way that this works is each file can have its own specific tests. So for example, you can see here for instructions.ts, I have something called instructions.test.ts. Same thing for assembler, I have assembler.test.ts. If we go ahead and look at instructions.test, you can see right now I only have a few tests for this one. And specifically, I'm testing my doBranch function. You can see as part of this test, the first thing I'm doing is just setting the program counter for the 6502. And then I'm just calling this doBranch function with various values to make sure that it does the proper thing for these relative branches. So for example, if I tell it to branch with an offset of 0, then it shouldn't change the program counter at all. And so the way that you write these tests is you say expect, you give it a value, in this case the program counter, and then you say what do you expect that to equal to. And these can be anything from numbers or arrays or strings or really any sort of JavaScript object. And I believe it'll do a deep comparison of the object to make sure that it's equal. So now that we've written these tests, how do we actually run them? That's where we actually need to go back over to the terminal. And similar to the npm start, there's also a command to actually run the tests. In this case, it's npm test, and I'm also telling it to do verbose equals true. So if I actually have any console log output in my JavaScript, that'll also come out in my tests. Let's go ahead and we'll just run this now. And what it'll do is it'll start up the tests, and you can see that it ran all of the tests and everything passed in both my instructions.test as well as assembler.test. The nice thing is this will just keep running in the terminal. So anytime I make changes, it'll go ahead and run it again. Let's go ahead and we'll just try that out. So let's go over to the do branch code here, and let's just actually put in a bug. So instead of saying, say, if the offset is greater than 127, let's just make it greater than 128. And then I'll save this file, and it'll go ahead and rerun the tests, and you can see that one of my tests has now failed. And in fact, actually you can also see that because I changed the code, it's also rerunning the actual interpreter here over in the web browser. Looking back on the tests, you can see that it failed on the test here on line 14, and it's telling me that it expected to receive the value 8191, and instead it received 8447. And so this just gives us a clue as to not only where the error is, but also what type of error. Let's go ahead and we'll fix that code. So I'll put this back to 127. And now let's look at some more complicated tests. If you recall, I had built a rudimentary assembler to make it easier to test out my code. Each line in my assembly code consisted of a 3-letter opcode followed by an optional operand, which is typically an address or a value. So if we look at my assembler code, there is a parse operand function which just takes that second half of the string, which is usually a number, and just parses it out according to whether it is a hex number or a decimal number, as well as whether it has one of these special addressing modes like the $X or $Y. So if we look at my tests now in assembler.test, what I'm doing here is I'm testing this parse operand function by passing various instructions through the parse assembly. You can see that I'm starting with an instruction that has no operand, so this is implied mode. Now here's one with immediate mode, so it's just loading a value. Here's another one in immediate mode, but in this case we're loading a hex value. And then we go ahead and test all of the various flavors of addressing modes. And then for some of the weird ones, like for example, jump with an indirect address, we can't use LDA because it doesn't actually have that instruction. Instead we use jump. And then finally there's a couple more. These are actually specific to the 65CO2, but we're going to go ahead and test those anyway. So if we now run this, you can see here all of the tests are currently passing. Let's go ahead and we'll try and make one of these fail. So for example here in our jump, this is a absolute indirect jump here. Let's just say instead of expecting the values 7C, 3, 4, and 1, 2, we actually reverse these. So here we'll put the high byte first and then the low byte here. And we'll save that. And when I do that, it's going to rerun the tests. And you can see that the second test failed. This test output from jest and npm is a little bit tricky to read. But essentially what it's saying is the difference between what you expected and what you actually received. So in this case, it's saying that inspected, I'm missing one line, but I received a different line instead. And then it actually tells you here, here's what it was expecting, and here's what it received instead. And then again, here's the line of code in the test where it actually failed. So we can just go ahead and we'll switch these back and save it and then run it. And now everything's passed. Now, what you'd really like is you'd actually like these tests to run not only here when you're actually compiling and writing the code, but you'd also like to run them over on Git. And this is where we can actually use Git actions to help us. To get these tests to run automatically when I commit the code to Git, I've created another file which is called node.js.yaml, YML. And this is in a subdirectory inside my directory called .github/workflows. And this is very specific to Git itself. So if we look at this file, I've actually just copied this from another project out on the web, and I didn't really make any modifications at all. And typically, for a lot of these GitHub actions, that's exactly what you can do. So I don't pretend to understand everything that's going on in this file. However, let's just look at the main points. So this is going to run on a flavor of Ubuntu. It's saying to use Node version 16. And then here are the various steps that are involved in actually running the test. So the first thing it's going to do is check out the code on Git. And then it's saying it's going to use Node, and it's going to use a specific version of Node. And then it's going to use this setup-node action, and this is just something that's provided by somebody else on Git. Okay. And then finally, here's the actual tests themselves. So first it's going to run an npm with CI, which stands for clean install. And this will actually just install all the libraries and start with a clean slate. It's then going to do a build of my actual TypeScript code. So this will compile everything down. And then finally, it's going to run npm test, just like we were doing over in our terminal. So once I've checked that in, now if I go to my actual GitHub repository, there is a tab over here called Actions. And if we take a look at that, every time I check in code to this repository, it's going to go ahead and run all of my unit tests and then give me the output from that. So let's go ahead and see that now. I think I have a few changes that I've done. So let me just see what we have here. Git status. Okay, I've got a couple files that I've changed. Let me do a git diff and see what's going on. Okay, it looks like I rearranged some code. Yes, that's right. I moved it out of everything was in interp.test.ts, and instead I moved it into instructions. And then I also made a couple other just minor tweaks. So let's go ahead and we'll add all of the code and we'll commit it. Rearrange tests for my commit message. Okay. And then I'll go ahead and I'll just push this to my repository. And now, once we have done that, we can go back over to GitHub and I'll just refresh. And you can now see that it's actually running my tests because I did a commit. All right, so it's in the middle of the job. I can click on the job. It's telling me that it's doing a build using node 16.x. And then I can see exactly where it is in the build. So right now it's running the npm with the clean install. Okay, and then it did the npm build, and that worked. And then finally it did the test. And you can see now I have a green check mark, meaning everything went okay. And if I want to, I can drill into these and see the actual results. And here you can see it ran my test. It told me that all my tests inside assembler.ts passed, as well as all my tests inside instructions.test. Let's go ahead and see what it takes to add some new tests. I'm going to create some tests for my interpreter. So let's just start with my instructions.test just for simplicity. I'll copy all this code. I'll create a new file. And here we'll save it. And we'll call it interp.test.ts. All right. And let me move this over so it's right next to my interp in the file here. Let's say we want to test the process instruction function. So in my test, I want to, instead of, let's see, we're going to do import process instruction. Okay, we're going to test process. This doesn't really matter what we put here. This is just what will get printed out when we run the test. And we actually probably do want to keep some of those imports here. So let me just copy that again and put that in because we're going to want to test to make sure that the program counter is correct. So if I save this now, it should rerun and you can see that now it's running my brand new tests even though those aren't actually testing what I wanted it to test. Now let's go ahead and actually test process instruction. Let's go ahead and we'll just copy this assembly code from display, put it over here in the interpreter, and import parse assembly from assembler. Okay, And then my code, let's just give it a single instruction here. We'll say LDA number string C0. And we need to make it an array. And then we also need to import bank 0. And we don't need any of these do branch things anymore. Okay, so let's see what we're doing here. We don't care about that. We're going to assemble this line of code. We're going to stick it into our bank 0 of Apple II memory. We're going to set the program counter, and then we're going to go ahead and call process instruction. Okay, there we go. Now, once we've done that, we should have the value C0 in our accumulator, and the program counter should have advanced by 2. So if we do get PC, I think there's a get PC. Oh no, actually we just have the PC. So now let's actually write in a test itself. So if you recall, the tests look like this. So we will just do expect program counter to equal 2002 after this is done. Okay, so that passed. And then let's actually make sure that our accumulator has the value C0. So let's see, instructions, that. So we want the accumulator, and we expect the accumulator to equal 0x C0. I think that's probably good enough just to demonstrate how to write tests. Now, let's actually check this in, and we'll go over to GitHub and make sure that it compiles automatically when we check it in. So let's just do a git status. Okay, one file, git add, git commit, add unit test for process instruction. Push that. Okay, go over here. Go back to our action tab. There's our test running. We can drill into that. Okay, and it looks like it was successful. So it ran my assembler test, my instruction test, and my brand new interpreter test there. So you can see where I would probably want to add a lot more unit tests for this as I added more and more instructions. But this just gives you the general gist of how to write the tests and how to get them to run automatically on GitHub. I think I'll keep adding more instructions to my code, and then maybe also try and flesh out the assembler so it can handle things like labels. So here in my sample code, you can see rather than just doing this strange branch to F7, which goes back here to the store X, what I'd really like to be able to do is just put in something like a label, like loop. And then if I do that, instead of here to branch to F7, I could just say branch to loop. So I might try to beef up the assembler to understand those type of things, just to make my sample code a little bit simpler, and then just keep adding more instructions and unit tests. If you do have suggestions on things that I should add to the code, or any mistakes that you see, or things that could be optimized, definitely leave some comments below, and I'll be sure to address those. I hope you enjoyed today's episode on the Apple II emulator. In the next episode, we'll continue to add more instructions, and maybe we'll beef up the assembler so it can handle labels, so we can make it easier to add in sample programs. If you haven't subscribed to my channel, please hit the subscribe button below. I'd really appreciate it. I'm getting very close to hitting the number of subscribers needed to get rid of unwanted ads on YouTube, which would be fantastic. Also, I have a Patreon if you're interested in supporting me that way. Patreon subscribers get early notifications about new videos, plus you get to have your name in the credits. I'll have a link in the show notes for that. Once again, thanks for watching.